Marcos Cruz is the director of the Bartlett School of Architecture in London. He's a person that he's working a lot with the new technologies and how these technologies are influencing design practices. He's working a lot with biotechnology and new kind of ideas that he will probably be introducing here today of flesh or aesthetics of flesh and the concept of flesh in traditional but also in contemporary architecture. Allow me to read a bit about him. As said, he's the director of the Bartlett School of Architecture in UCL, where he's also a reader and studio master of Diploma MArch Unit 20. His varied teaching activity has been carried out at University College of London, University of Westminster, UCL, University of California, Los Angeles, Tunghai University and Feng, Chia in Taiwan, Royal Danish Academy of Fine Arts School of Architecture in Copenhagen, among many others. Cruz studied at the Escola Superior Artística de Porto. He gained his master's degree in London with distinctions in architectural design at the Bartlett, where he also got his PhD in 2007. His investigations about Neoplasmatic Architecture, which is also the title of his conference tonight, focused on a contemporary discussion about the body and the impact of biotechnology on architecture. And his research on that topic won several awards, such as the RIBA President Research Award, and more. In his practice, Cruz founded with Marjan Colletti the atelier Marcos and Marjan back in 2000, where he's investigating, where he's taking, let's say, his research and apply it into practice. So thank you very much, Marcos, for being here tonight with us. You didn't have the opportunity to have a very quick look at our institute. You will do that later. But the work that we're doing and the work that you are doing, I think it's quite like have a common base, and that's interesting. And thank you for being here.
Now it's on. Ah, right. Thank you. I'm changing completely the environment where I was just half an hour ago. I was with Josep Mias with my Spanish chip in my brain, sort of presenting some projects which we have chosen for an heritage projects with a much older audience, with a much more serious audience than what I have now. So I'm just sort of in a split world right now today. I just thought to put a few thoughts together for tonight. It took me a while to think, what should I present to the IAAC, to the audience of the IAAC? I was not quite sure, and it might not even be the right thing, because I had sort of other topics as well which I wanted to discuss with you. But when you have an hour or an hour and a half, that's the time you have. I leave it maybe for a few questions and conversations afterwards, some other topics. But I was thinking to discuss the Baroque and the relevance of that. I was thinking to discuss a few issues about depth in architecture, but then I thought, no, maybe the bio conversation is maybe more interesting at this stage. The title Neoplasmatic Design is something that comes from the publication I edited in 2008, which is now a few years ago, but it was sort of a summary of projects which were dealing with living matter in a way. And although many of them were only design projects, but the idea was that living matter is actually design material. It was not seen, all these projects were not seen as sort of only conceptually thinking or by analogy. There was really a serious understanding that if something is growing, the challenges are of a completely different order. The subtitle, Architecture of Multiple Ecologies, is that the word ecology is one of the sort of most used words that you can get now. Almost anything that you're doing is a sort of an ecology of some sort. And I think there are sort of many different types and multiple interpretations, and I might give a few, and you might have your own interpretations. Maybe to just for a start, I think this term and prefix bio is probably the most important prefix we have in nowadays. I mean, there's literally nothing, as you can see here, that you cannot just add the bio prefix before it and sort of turn it into a new concept. And, you know, from the more traditional biochemistry and bioengineering parts, you get sort of the biopolitics side of things, the bioaugmentation side, the biomimicry, obviously the word biology, where it initially comes from. And clearly, I think all this has to do with this sense that our environment is becoming increasingly more biological. And you have authors sort of in the 90s already speaking about this. Kevin Kelly was one of them. And really this notion of the biologicalization of architecture is really a fact that we cannot simply avoid. But what does it mean really? I think there's a lot of sort of flirting going around with the bio word as well. Now really, sort of one of the key books that influenced, that you might be all absolutely aware of, is On Growth and Form, which in the sort of mid part of the 20th century really had a profound effect on the first biological thinking. But the biological thinking that this really implied was structural and morphological to a large extent. Before that, we have a sort of really long period of a much more decor or ornamentation-related understanding of biology, where literally our buildings, and you know, you just need to go around this city here, where you have sort of half of the buildings decorated with all these sort of extraordinary patterns. And this is sort of a Louis Sullivan case, where, in fact, what architects were doing were reflecting the discoveries that biologists were making. That's basically the main point. And you get sort of the Darwin sort of discoveries and the excitement that architects in their usual inclusive nature of just grabbing whatever is being done elsewhere and bringing it to their own practice was happening here. But On Growth and Form, as I said, introduced a sort of geometric understanding, I think, of real key relevance. And I won't delve into much into this because it's sort of known territory, but really the sort of biomorphic structural understanding that engineers and architects applied, you know, from the most tensile thin structures of nets or seashells, you know, the application on the Olympic Park, to bubbles. The Friotto phenomenon obviously was key, the Bucky Fuller case. And you can see how this stuff actually didn't die. It continued existing, and you just get the Eden Project and quite a few others, where really the structural and now / environmental biomimetic thinking is really in place. I have been sort of 2 years ago to a conference in the north and the east coast of the United States, which was about biomimicry, and I realized that there was a whole group of sort of people hanging around or developing around this idea that biomimicry is a completely new thing. It has never happened before. And they seem to be sort of blind believers that nature as a model is so amazing because it developed in the last sort of 15 millions of years and now it achieved perfection, and therefore what we need is to copy and apply the principles of nature. Thank God there was a biologist in the conference who said, look, this is complete and utter bullshit. Nature is not at all in its perfection state at all. Nature is constantly in its state of imperfection. In fact, it's evolving constantly, so please let's not fetishize this idea of biomimetics, because it just often doesn't apply. But there are indeed interesting principles. Now this one here for me is an aesthetic one, which for us obviously is interesting, and is the fact that this sort of embedded translucent matter interests us. And sea plankton and all this tiny stuff that we sort of 50 years ago had difficulties in visualizing has an impact. And you just get the sort of very simple case, the fetishized sort of object of the mouse of the Mac, or the iMac at the time in its first version. You know, we all found it absolutely beautifully designed because there is something that intrigues us that we still like, which is that technology is embedded in this sort of plasma of translucent matter. It just is incredible. And it clearly comes from a tradition where the duality of opacity as opposed to transparency, which the modernists like to discuss, moved on into this idea that translucent conditions, I call them rather inlucent conditions, which are, if you take a building of Grimshaw, and clearly there's the fetish of the stuff that is embedded within, that is lying within, really interests us. We like that. We are not interested in the opacity of conditions, neither on the transparent ones, but it's this enigma that something absolutely intelligent and technologically potential lies within. Another condition is really the small, micro, and nanoscale. I mean, the whole issue of genetic engineering and how embryonic cellular stuff is what biologists are fascinated with for quite a few years. You know, and you get the Greg Lynn case with his embryonic house, and there's a clear sort of direct translation of the embryo idea, the cellular specific customization that can exist to different people can happen. So the idea that the cellular principle hosts and sort of data that is the same, but then the morphological development is in each case different, is something clearly that comes from a reading of biology, nothing else. We, in our own case with Marcos and Marjan, we were sort of fascinated with the coral a few years ago, and how that sort of structure sort of influenced the project we did here for Spain at the time for Badajoz, where there's a sort of rather ugly postmodern building, and they asked us sort of to do a new entry point for the building, and we sort of worked on this hyper-ornamented set of surfaces where the shadows in this sort of heat of Badajoz could create this rather in-between interior and exterior space. And although, as I said at the beginning, I'm not going to have time, but I'm fascinated with the idea of depth. I'm absolutely horrified with the idea of the flat surface, of the sort of obsession with flatness and lack of depth. I like the stuff that has sort of mass and needs a bit of time to get into. And so in this set of pavilions that had this large canopy, really the idea was to embed light and trap light within it, but probably also have a set of functions and create really a sort of atmospheric mood through the ornamentation of the building. But, you know, as I was saying, you know, the influence of stuff that interests us is, you know, again, sort of a microscopic image of some sort of underneath the sea cells, and, you know, how that almost immediately has an application on the Selfridges building of Future Systems a few years ago. And again, in my case, when I was doing the masters in the late 90s, these were the books that I had on my desk, because they were simply much more fascinating. They were intriguing. I didn't know exactly what they meant, but to imagine that the architectural sort of environment could be of this sort of nature, where everything looks alike, but there's also everything is different, made me at the time, in a rather naive, intuitive way, there is a funny sound here, work on these models where I was just incredibly bored by looking outside the building and see every single morning a sort of Victorian building with its windows. And I like to think that maybe the facades of buildings could be much more dynamic, inhabited facades. I have to say this triggered the whole PhD that I did on notions of flesh and notions of inhabitation of these three-dimensional facades. But here in this case, the idea of really wearing these exoskeletons, which were the facades of buildings, and do virtual communication with them in them, and transpose the activity from inside a building to the outside with latex and rubber materials was an interesting idea. What I did not know was that very soon after the masters, Peter Cook and Colin Fournier were invited for the second round of the Kunsthaus Graz and asked me to join. And these ones were sort of models I was doing during the masters. And this was the first model, which was the latex model, the first really three-dimensionalization for the Kunsthaus Graz building. And the thought was all about a biotechnological building. It was not at all about archigram, as many people have written about. We never discussed actually archigram. Peter and Colin and we 3 other guys who were there, the young guys, did never really talk about archigram. It was all about Guggenheim, New York, actually. It was about circulation routes and experience and what do you see and what do you feel. Anyway, historians make complete misinterpretations of reality. What we did not know was really that 3 years later, you had the building built, and I know that Peter Cook is coming soon. I guess he's going to talk you through his sort of complete awe when he came back from Graz every time, not believing that this thing was really being built. I have to say, what still interests me in Graz more than anything else is the fact that it's a really experiential building, and I think the notions of experience, I wouldn't use the word phenomenology because it's sort of, there's a connotation with it which I think is, we need another lecture for that, but at least the experiential side I think is fascinating. And as I said, Graz, if it had something to do with archigram, was the spirit of it, which was to believe that it could be biotechnological, but in reality the technology is not available, and therefore it had to be built as a media facade and with more traditional technology. But it fits into this sort of belief that biological material is clearly influencing the way in which we are challenging complex geometries and the way of making. You get the Toyo Ito case clearly. I mean, I have to say, I just came back a few months ago from Taiwan, and this is probably one of the worst ever buildings you can ever get, which is the Taichung Opera House. It's just horrific, but I mean, Toyo Ito is an amazing architect, and he's just trying his best to get this building off the ground, and it's just not working. People are horrified. What is indeed working, if you think, is this whole biomimetic condition on a much smaller scale. There are indeed applications that you get, the famous Velcro is one of those cases where something was analyzed and then applied on a small product. So the product designers, I think, and engineers are having a pretty good take on biomimetic thinking, much better than the architects. I mean, this is a sort of famous case of the windmills where the aerodynamic capability of the wings comes from the analysis of whale fins, and once you have the sort of irregular shape, it just is able to flow in the wind much quicker and therefore produce more energy. You get another sort of known case, which is the Shinkansen bullet trains, where they had this really terrible problem of noise because of the speed, and the engineers, they studied the kingfisher beak and realized that when the kingfisher jumps into the water, there's a sort of aerodynamic capability that managed, or make them manage to control the sound impact of these bullet trains. And this goes on and on. I mean, you just Google stuff and you get sort of a whole list of things, artificial photosynthesis of trees is a whole thing that people are getting involved in. And I come back again, the visuals and the fascination with the microscopic and nanoscopic scale and the genetic impact that we're having on it is really what I think is affecting the design world, which is this extrapolation from biological thinking. Stuff from people at IAAC or Eric Verne with, I'm sure with quite a lot of stuff that is going on here, which I have seen as well, where clearly the cellular patternization or the sponge principle and typology is sort of seen as the real interesting challenge. Or stuff that I like a lot that Neri Oxman has been doing with this sort of multi-material 3D printing, with these sort of ecologies, as she calls them. In fact, they're not really ecological at all, but they feel like a sort of ecological diversity, at least from a visual material point of view. Now, I thought that, I'm personally interested in discussing technology and digital fabrication within a context that has to be broader. I have to admit, when, sort of 10 years ago, and maybe even a bit longer now, sort of the early 2000s, when you were sitting in crits all around, and some people were really, really obsessed with conversations about scripting and finding sort of performative qualities of stuff that was parametric and so on. I found it was amazing, but I didn't spend any time with our students doing it, I have to say, because I was a believer, as I'm still now, that the stuff is so obvious that it's piercing into everything what we do, then I just like discussing other issues as well that architecturally makes it more interesting. I think once you have somebody discussing digital fabrication techniques of the most advanced robotic manners and combine it with cultural conversations, I think they become really interesting. Once they are only about the technique itself, the technique will become old and then will be surpassed by somebody else who sits at Columbia or SciArc or somewhere else, and then you think, oh gosh, you know, the IAAC is actually out of time, or the Bartlett is really now old-fashioned, and I think it becomes a bit silly and rather reduced. So what I'm going to show you is a few topics that interest me, that none of them is a linear path. In a way, it's a sort of juxtaposition of thoughts. I think clearly one issue that you, I think, by just looking around from sort of the corner of my eye, you are surely very interested in is notions of materiality and probably this idea of digital crafting. I like the word crafting. I think we cannot take it out of the equation of computational thinking. And that is the mastery control of the craftsman, being it by hand or through tools or whatever, I think is a level of achievement. You know, you just need to see the Gaudi stuff, for instance. Without the level of crafting that was implied there, you could never achieve what these buildings were, ever. So material testing and crafting, for me, is something that is sort of part of how we think and do. Now, these ones are almost archaeological pieces already. They were sort of done in the early 2000s. These are sort of what we call the NURBSters. They were just sort of simple 2D, 3D notching techniques. I have to say, we still do some basic stuff like that with students from time to time as a sort of gymnastic. It's just quickly get them to sort of 2D, 3D, notch a few bits. These ones were sort of different installations done throughout the years with different materials, with different notchings in different directions. Pretty straightforward stuff, but clearly what I think was interesting was the notion of expression. Is that when you do 2, 3, 5, 10, you get to a point where you become sort of the master of your technique and you start talking about other things. And this one, I think, was rather successful, although from its technique was probably the most primitive of all, because it was just striated, sort of laser-cut MDF stuff, or plywood. But the idea that, you know, BD, this building design magazine, called it as a sort of orgy of Bernini, Rodin, and Gaudi, meant that probably they didn't really understand what we were doing on the one hand, but it also meant that there was a level of Wunderkammer, bizarre depth of hiddenness with a level of expression that we quite liked. It was sort of starting to talk on its own. It was not only about that. Actually, in fact, you forgot what sort of basic technique it was using. And I think that was interesting. And the students all felt sort of ambivalent about it. They felt, well, it's really primitive in its making, but in fact, it has an expression which sort of is quite nice. And maybe that leads to other conversations. This was another one of our exhibitions. We are just sort of 10 days of our final show on the 21st, and every year there's this sort of anxiety and excitement going on of what are we all going to build. That was in 2006 or 7, where there's a sort of basic NURBSter underneath, which is a sort of notching bit, and then a few Korean paddles, as we call them, that were adjusted, and then a whole set of models with different techniques on top. This one was another one done a year later, and another one with more sort of milling techniques. But as I said, I think materiality is really something interesting, and we in the unit started 2 years ago for the first time to invert the pedagogy, which was to start to let the students really deal with materials before anything else. They didn't even know for what program, what they were going to do with it, but sort of question the condition, the chemical properties, the material properties, the aesthetic properties of materials. And you get really an extraordinary array. And I personally, I'm fascinated when somebody can also cross-bridge the different tools that you need when you go from subtractive to additive systems, from sort of 3D printing to, and different modes of that, into laser cutting, and then crossbreed into sort of stone milling. And you sort of become fluent in all of those. And the compatibility, but also the difficulty between these ones, I think is interesting. And clearly when you bring that sort of together with, you know, basic computational tools, like that one was sort of an old notching manner, sort of almost like the IKEA booklet that the students needed to put it together when you have sort of 350 pieces and they have to go in one after the other, otherwise it's, the whole thing doesn't work, to obviously sort of more robotic principles. And this was actually Marjan Colletti, who's my teaching partner at the last Smart Geometry in London, with robots and the sort of the stretching of foam and the sort of careful control of this almost chewy stretchability of foam material, which I think has quite sort of extraordinary properties to be explored. This was actually a student of ours who a few years ago, who actually was here when you had Smart Geometry at the IAAC, she came. And she was one of those who did a sort of project in central Taipei. And clearly, beside the programmatic conversation and the functional distribution, etc., when she was doing her models, you know, a bit along the lines of what Louis Kahn was sort of saying, the way you do your models is the way you think your architecture, and you in fact will become the maker of your architecture. There's a sort of correlation. And she, in the sequence of models that she was doing, that you can see how they sort of are gradually evolving, she started intertwining, like in this final piece, 6 different techniques, which, do you know, was quite liberating, at least in our context at the Bartlett, because there were clearly those who were all doing 3D printing, or those who were laser cutting, or the other ones that were sort of milling, the other ones using vacuum forming, the other ones that were starting to do some sort of robotic stuff. But there was nobody that was able to do them at the same time. And the sheer fact that there is this rather sort of exuberant language that comes from a model that intertwines all these different techniques together, and there are 6 of them, was really quite sort of interesting. I mentioned these issues of the inlucent, and clearly the translucency and lucent condition. You know, you get the old Mies van der Rohe principle of the modernists, the translucent condition of Rem Koolhaas for his library project, the French library in the 90s, and I mentioned already the project of Grimshaw, and I say it again because I think the materiality that has this sense of not being layered, of not being based on the sandwich, the materiality that is much more almost like the Barbarella case, plays with something that is within it, really is a big challenge, because it's also a big challenge not only in how we do it, but how we inhabit this stuff. And this is sort of my own images when I was a master student and sort of shaved my hair and took my clothes off at the Bartlett, and it was sort of my intro into the school. I mean, it was clearly sort of take your past off and, hey, here we go. There's something different. And the idea that our environment has probably materiality which is getting very close to our own skin is still something that fascinates me, because the notion of artificial skin, or that this duality between the living and the non-living is surpassed into something that this is living and I'm living as well, I think is hugely challenged. But I leave that for sort of another conversation a bit on another time. New materials, I mean, look, you know, from the sort of stuff that you get gosh, I forgot the name of this, the ductile stuff of concrete, which is hyper-stretched and amazingly resistant for very large spans and very thin work, I think is pretty interesting. You know, translucent concrete is sort of also interesting stuff to look at. Bioplastics, the whole bio world of materials. Bioconcrete, I mean, I've been talking about bioconcrete for a while, and clearly I missed inviting him this time round, but next year it's one of the masters to get Jan Honkers from the TU Delft to talk about bioconcrete, because he's really the person who has been sort of working around this. The stuff that I published in the AD in 2008 was looking really rather grotesque and ugly. And the feeling was that, look, he can't stop it. Once you have these extremophiles in the concrete, it never stops growing. Once it's inside it, it doesn't stop. Means I think one of the difficulties to implement bioconcrete is really the process of living cells don't stop once you don't program them to stop. And the sort of excrement that it creates, which is the gluing binding element for concrete, becomes at the end really a problematic case. This is really quite interesting. Jinjia Dozia at the University of Sharjah with these biobricks, and there's a whole environmental agenda around this. When you think that bricks, rather than being this beautiful vernacular material, is amazingly polluting because you have to burn these bricks, and these trillions of bricks every year that are burned create enormous emissions of greenhouse gases. And clearly what she is saying is that if you grow them like a coral, they're very resistant, you don't burn any piece of brick. It will be interesting to imagine once these bricks continue growing and they start growing into each other, that will be sort of bizarre if you have these grips that after a few years they might look a bit like the Sagrada Familia in one sense, sort of where the stuff sort of never really stops, as it actually happened with this stuff here coming from the States when one of our students got this material, which is the waste product from wood and from the wood dust. And when the binding material is fungi, and the fungi really with its root, the only thing that it does, it binds this material together as a waste material and then joins it into a very resistant sort of environmental panel. But when our student got it, it looked beautiful when he had sort of these big sheets. 2 weeks later, they were completely bent because the stuff still was responding to humidities and so on. So you know, I mean, growing stuff is not without any problems. It brings with it its fascinations. François Roche with corn, biomaterials, and this idea that there's a sort of sprinkling with water creates a humidifying decay process. And again, I think there's an interesting conversation about when the material is actually decaying and not resisting forever. I now sort of divide, I think, in, I would say, 3 main categories when you get to the process of making and materiality. What I call the topological permutations are much more surface bound. I think there is an enormous range. I mean, look, I wouldn't dare sort of even to start expanding on this. I just show you a few things that I find interesting. This was a student of ours, was an almost illiterate computer or computational person, who in fact was a really refreshing mind, sort of now 4 or 5 years ago, who joined our unit by saying, look, I don't want to sit in front of a computer at all, which for me and Marjan was really shocking, because we thought, look, how dare you sort of even suggesting that? But we knew her from before. She was one of the most talented characters we knew in the school. So she came in, and I think we convinced her to learn some very primitive Rhino commands, sort of doing some cones, intersecting them, flattening them. That sort of was about what we managed from her. And using a sort of laser cutter. And, you know, we had to be really careful, because every time the other ones were sort of heavily modeling and doing complex stuff, she sort of was saying, no, I'm not interested into that. But her interest was into Baroque anamorphosis, into patternization, ornamentation. She started looking at Houdini's theater stage, the whole issue of magic and architecture, the whole conversation about who is the magician. Is the architect the magician? Do you do the space for the magician? Is the architecture that you produce in itself a piece of magic? Where is the magic itself? All these ones were sort of stuff that she was looking at. And one thing that this lady had was an extraordinary intuition with her hands. And do you know what she started doing is, you know, creating a lot of very rigorous studies of intersections with these cones and so on, and laser cutting, and then creating sort of structural elements, and gradually constructing these actually rather beautiful models with a very personal language. I'm only showing you 2 images from a huge array, which created a complete reinterpretation of what a stage and an auditorium for magic can be. The background of this was a field trip to Rome, only to Baroque Rome. I mean, really only looking at Borromini and Bernini and some other sort of characters who were looking into conditions of this depth, where I think it's fascinating if a space looks great and grand and it's actually tiny small, simply because the mathematical capability that the Borromini had to influence the geometry in such manner that he can amplify something magically by being in control of his geometry, I think is fascinating. This is the sort of stuff that this lady was interested in, with the idea of the old sort of elephant or Houdini that at the end disappears in this bizarre stage scenario with these different light cones. In fact, another thing, which I'm actually said I should have put an image in, is when she thinks that the cone is not, by the way, a geometry that in the early 2000s everybody was using. It's more to do with the fact that if you have a light cone in the dark space of a magician, in fact, the architecture disappears because it's completely pitch black. The only thing you have is a cone of light with something happening there. That's actually the only thing you have. At the same time, we have our visual cones. Meant the intersection of the visual cones with the light cones became the intersection of the architecture that she was starting to create, and the way in which the audience was looking at the architecture from particular angles, and the light incision was coming from particular angles. Anyway, look, the whole issue of these surface conditions where you create depth in something very flat. Bas-reliefs, I think, are quite interesting. You know, this the sort of Renaissance bas-reliefs where perspectival distortions were created, where actually they're pretty flat. These ones are sort of a few centimeters deep conditions of perspective. Or this was actually somebody, a student in Lausanne, who was creating this script in order to create the depth of a piece that was rather flat, but it really felt as if it sort of was bulging inwards, simply because the script was creating these distortions of the geometry to create this depth. In terms of all this, I think the Ali Rahim performative quality of some surfaces, I think are really quite wonderful. I mean, he probably has given talks here and explained you the work. I just, in the context, I think it's really beautiful stuff of taking these very simple principles of a material, which doesn't have to change mechanically or through any electronic input. It's only our intelligence of knowing that the material is sensitive to humidity, and therefore it sort of changes its capability of filtration, is very smart. It's amazingly smart. And if you create the sort of right script for the right pattern, then you are just in control of the mastery of the project. This is another type. This is our own, Marjan and I, our own pavilion that we did last year for the London Olympics, which was all about the challenge of creating a simple surface, similar to the project which I showed you at the beginning in Badajoz, which was a sort of large canopy, which we wanted as a challenge, that you create this rather heavy canopy, completely perforated, flying as a piece of paper, as if it's sort of amazingly light, and it's actually, I think this piece is sort of 10 tons of steel, sort of incredibly heavy. Now, for us, the challenge was also not only to patternize the piece, but to have double steel curvature technology that the manufacturers in Germany were using. And they are the ones that do all this work for Anish Kapoor, where double steel curvature is done in the cold manner, so there's no heating of the material to deform it. So you get sort of the scripts of the engineers of Bollinger and Grohmann in Vienna doing a particular script and software for the structural capability of this perforated mesh, and then the makers in Germany doing this double steel curvature, as you can see here. It's all without any dilatation of the material. And we spent sort of 3 months discussing how the hell can you do double steel curvature with holes. I mean, these ones were shipyard people, so they were doing boats. For them, it didn't make any structural sense at all to perforate a surface that as a surface has amazing structural capabilities. Once you put holes in it, it doesn't make sense. It becomes completely useless. So for them, it was sort of the big challenge. But we gradually managed, between the pre-perforated and the post-perforated process, to have that done, and still have something that could stand up on its own feet, with all the English regulations of public squares, which are sort of horrific. But it created sort of this pattern, and in a way, still the illusion that the architecture starts becoming sort of like a set of leaves. And when you have it then in really on site, it creates sort of a mix between what really the trees are and the sort of the negative petals of the architecture. I still think is sort of rather beautiful. Again, I think the notion of expression and that you get sort of a control where you say intuitively the thing is right, and you can't explain it rationally, but you just think, no, it's the right moment, we need to stop now. That's the pattern we are looking for. I will show you some more stuff about this installation a bit later on. I think another big topic is this subtractive logic, and this for me is not a technological thing, it's a mental thing. You know, I think probably in this group of you guys here, you have the sort of subtractive minds and the additive minds and the topological minds, and they're sort of the different mindsets somehow. Still, one thing that really interests me is, you know, rather Bernier than being an architect, I think his sculptural stuff is much more interesting, simply because he's capable to work with his material in such manner that it starts speaking like another material. I mean, we invited Kiwi Sotama the other day, and without having us ever spoken about it, we sort of just said, look, we're talking about exactly the same thing, which is if you are in control of your material to such degree that the material doesn't feel like the material it is, and then you think, my goodness, sort of 20 years ago, people were still obsessed in architecture schools to discuss whether the material is truthful or not, or it's fake or not. It's complete absurd. It's actually about, you know, marble becoming flesh, human flesh. I mean, it's more human flesh than, I guess, really some flesh in reality, because it's so amazingly haptic, because it's so incredibly well controlled. And we, in a sort of more humble way, tried this when we did this exhibition at Christchurch Spitalfields, which is this beautiful Baroque church in East London, when our topic was the Bernini folds. And we, with the students, were saying, look, let's mill the foam in such manner that at the end it doesn't come across like foam at all. It has to behave like something else. It has to really feel like another material. And so the idea of the fold and the fabric, so foam, I mean, it was completely and utterly computational, but all the software that had to be tried in order to feel as if there's a sort of weight of a piece of fabric, of velvet, looked rather simple, but was incredibly difficult to achieve, I have to say. And you got all the sort of those people with Maya against the Rhino guys and the 3D Studio Max guys and the Cinema 4D people and the processing, and so they all were trying sort of next to each other, saying, now I will manage to get it done with the right weave and feeling. And it was, in fact, a guy with Cinema 4D who did something where everybody stood up and said, fuck, that's fabric, that's really fabric, that's not foam anymore. And it clearly comes from not only the geometry, but then how afterwards the milling from two sides and so on is to sort of controlled in a manner so that it then sort of scratched. This is Guan Li giving it the final touch. And I say another thing here, which is another parenthesis. I actually love the final touch of one sort of sanding something, because in fact it was sort of about the imperfection of the technology. It didn't really work exactly as we thought. But just before we were doing this installation, we went to La Tourette, and everybody was sort of sleeping in the cells. And I really liked La Tourette, not so much because of its great composition. It was really the feeling as if the craftsman just left 5 minutes ago. There was a level of imperfection, of somebody at the end scratching some things that actually mess up completely, probably, the perfection of lines and geometries and passages and perspectives that Corbu had in his mind, which I rather liked, actually, the whole sort of texturized walls. And from my experience, when I was a student in Barcelona, for me, one of the most horrific buildings is the Museum of Contemporary Art of Richard Meier, which is sort of trying to avoid that texture exists and the material has to stand its time and being always this white sort of absurdity. I like the lack of perfection and the fact that at the end something has to happen to get it right, and then get sort of the right geometry where I say, yeah, now it's actually speaking the right language. Now it's actually really doing the right thing. And so there's a sort of analog digital somehow boundary which I'm fascinated with. This was a sort of piece we did for the Royal Festival Hall. And this one is a new one we are working on, which is rather more complex. The Arquimera, which is going to be a facade for Lisbon for a chapel, which is a much more three-dimensional piece where all the milling technology has to be sort of done in a rather more complex way and has to be clearly sort of cut in different manners in order to achieve this. So the whole puzzle of integration of elements will be the real challenge. And obviously the 7-axis milling and so on will be what is going to help us doing it. The last one, actually not, is the pre-last one, is the additive ecologies. Is when the mindset is about adding, is the sedimentary sort of thinking mode. I'm a big lover of Fisac, and I have to say I have seen now Fisac a lot being mentioned, and I think 10 years ago Fisac was a completely forgotten man, maybe in Spain just about around Barcelona, but you went abroad and you were talking about Miguel Fisac, nobody had a clue about Miguel Fisac. But Fisac is a trendy character again, because this bulgy stuff. In my PhD, I spoke about the masters of bulging, and there are quite a few. The guys that like a fat belly, or they like something that sort of rather shapeless and has a sense of matter and mass, and goes completely against the 20th century obsession with the thinness and the lightness and all this the stuff like that. Now, I think Fisac is amazing because it doesn't only have the level of fat and depth, but it clearly has a sort of thematic repetition, which we nowadays, with our technologies, can really take further much more. And I show you a set of sort of 3D printed models of projects which step into a territory which is the sacred and the sublime, which we in the unit always explore. So every year there's sort of 1 or 2 people who get into this. Which is when architecture speaks about other things, which means that the physicality around you has symbolic, I dare say, symbolic qualities, or simply sublime, transcendental feelings that you can't explain, you can't rationalize. And today was a very nice moment, because when we had a sort of lunch, Elias Torres Tur was there, who was my teacher here. And Elias Torres, he was a really sort of amazing figure at the time, because I was part of this Complementos de Proyectos de Paisaje. But this guy never spoke about paisaje at all, so there was no landscape conversation whatsoever. He was talking about Velázquez, the painter Velázquez. And everybody was sitting there thinking, like, why the hell is he talking about Velázquez? I mean, Velázquez was by far not a landscape architect or painter or whatever. But Elias Torres, in his, I think, crisis of his 50s at the time, his existential crisis, was trying to question why Velázquez was not the best painter, but he was the best painter. In other words, technically speaking, there were people who were actually more amazing. Some people who put the gaze of some other people in the best manner position, others where the light was even better, some others where the composition was better, some others that had better sort of techniques of using painting. But Velázquez had something in his sort of level of imperfection. This is beyond what you can explain. It just transcends you. And he was saying, look, what can you discuss in an academic environment and as a practicing architect that allows you to achieve something that goes beyond? What is that? What are the rules? How can you discuss that? And somehow what I remember was that there was no recipe. I think he didn't find it. But my own interpretation, because it never left me this question, was that maybe the response is on the multi-layering of thought. It's when somebody starts talking about 6 or 10 different things simultaneously, and they're all pretty valid. And once the work becomes rather incoherent and even eclectic, and you have somebody trying to explain and say, well, you know, it's about technology, and it's actually, I'm sort of interested in the way of how you inhabit the thing, but I was looking into neo-Gothic as well, and you say, hey, you know, stop it, look, what it's about the theme. I think then it probably is getting rather interesting, because there's something in between that might make historians be puzzled, and they can't get their head around it. And that's why they still are trying to demystify Le Corbusier, and why this guy put a squarey hole when he had a circular staircase leading into a thing that had a white and no black pole with a bit of white light coming. I mean, why the hell did he do it? I don't know. Probably because there are sort of 20 different manners in which you can interpret that. And if this is part of a conversation that I think the sacred spaces really have embedded within them, because you can't turn them into one-liner, ever. I mean, the most amazing spiritual spaces have so many juxtapositions of thought. And this is sort of what these projects were about, you know, what we call more the figural rather than the figurative. Rather than talking about, and this is clearly probably the most figurative, mimetic, figure-related project, but many others have to do more with a language that is sort of rather computational. But the fact that, as this was called in London, the Gaudi on acid type of person, you know, the idea that the conversations of this guy looking at Cuban hybrid Santeria, sort of mixed Catholicism with some bizarre rituals of these sort of gurus that believe in forgetting now all the terminology of rituals, and so I mean this thing that you can't get your head around it because it's actually pretty irrational, is what created that sort of facade. And all these guys obviously fascinated in making in technology and computational language, without any doubt. These are sort of catacombs, chapels, where the convolution of space, the interpenetration of certain geometries and spaces with a very rather complicated circulation route creates these sort of things. Marjan, I think, in a very, very sort of astute manner, called it the art of exfoliating. You know, when the architecture skin exfoliates like skin, when it starts sort of peeling off into that sort of stuff like that, where the architecture sort of starts sort of emerging into something like a blossoming of the flower, which doesn't stop, it's actually in movement. And this was a sort of chapel extension for the Basilica of San Clemente. And today we had a conversation about you, Josep, telling me that we are still far too paranoid in intervening in all buildings. You know, you get the Cathedral of Barcelona, who would ever dare to intervene there? I mean, apart from maybe just about a pattern on the floor or some very minor thing. Somebody designing a new extension of a chapel or a window, we wouldn't dare. And we really were thinking this whole theme is about breaking that, because there has to be a security that we have with our own language to break through that. These ones are sort of stereolithography models, and so this 2D, 3D compositional stuff done. A bit another person working with this hybridity of laser cut striation with 3D printed bits. This guy was the first one who, at least in the Bartlett, was printing in color. And that in itself was interesting, but we thought, okay, you know, control of how deep the color layer is in the 3D printing was a whole issue. But I think much more interesting in the line of the spiritual engagement was him designing this ceiling here, which is an acoustic ceiling. On the one hand is the chamber of whispers, which is an anechoic chamber, as a matter of fact. And so his technical dissertation is about the total absorptions of sound for an ecumenic center of Turin. So this idea that the Pope gathers with all the priests around the world, has this ecumenic center which doesn't exist, of the Council of Turin, but discusses in this whispering tone about the issues of religion, which is created with this ceiling. One thing you can't see here, and unfortunately there's a problem with an image that he doesn't have, which is his studies into the Gestalt theory. And at the same time you see the acoustic qualities, is the fact that the Gestalt theory tells you that if you look at this here, and you close a bit your eyes, it sort of becomes an abstract image. But within any abstraction, you might start reading animals or figural sort of elements in it. And the idea here was that there was a study in which you could read across from a particular angle through the sort of maze of bizarre abstraction of all these anechoic prisms. So this is just to tell you sort of a bit what the conversation about these ones. This is just a student who is just finishing right now with this sort of object print of this building that literally listens in a city. I mean, these mirror shells that come from observations of these mirrored components that were used in the Second World War by the English to listen without before the radar, to listen to sound in a distance, is what she then used with her acoustic studies to listen to sounds in the city that are much more far away, literally because the balconies have exactly that capability of listening. She did another thing, which I'm not going to into it, which is an audio brick, which is a quite, I think, revolutionary idea, but that for another time. Anyway, fourth point, which is my last one, is about biological manifolds. I think if you get the topological, the subtractive, the additive, the biological is really, again, on a different nature, William Katavalos, which is the sort of person who in the 50s came about with this wonderful idea, which I still quite liked. You know, you take a seed, put it in the earth, and after a few years you have your chair there. Or he was even going further to grow a whole city. It's absurd, but it's sort of rather beautiful. You know, it's by this idea that you codify the cellular piece in such manner that it can really, with its own data, grow into something and differentiate. I don't know, did you have Michael Hensmeyer here? You should invite him. Michael Hensmeyer gave a fantastic lecture the other day, it was actually last year. And one of the conversations that came out of that was that the whole, you know, the whole issue of geometric permutations and variations that sort of unfold through processing allow, through these cellular pieces, to create objects that at the end look incredibly alike sea plankton, very much alike sort of cellular structures. But one thing that computation still doesn't do, it doesn't differentiate. It multiplies, it subdivides, it differs, but it doesn't differentiate, as the biologists say. That means that if you have something with a code as a cell, the initial cell or agent doesn't have a code in itself that can turn into something that is differentiated into a liver or into a skin cell or into an eye cell. That level of intelligence, something that is probably a sort of next step. Bloody complexity that this will imply, but I mean, this is what sort of is underlying this, which is clearly, you know, Peter was playing without knowing anything about any scripts or any real biological work, but his veg houses, or veg house is to do with this hybridization of something that is growing and is artificially produced, and the intertwining creates a new hybridity that is fascinating. I went to Taiwan actually very recently, and I went to see the tree house in Tainan, and I just thought, fucking hell, they actually have the veg house that Peter Cook was designing. You know, this is, you know, the roots of the banyan tree. It's just amazing. You know, you construct any scaffold and this tree starts growing around it, creates the shape of the thing, you take the scaffold away, and then it remains like exactly what it was. And it keeps on growing for decades and centuries even, and becoming this enormous beast that actually the trees grow into each other as well. So Marco, banyan trees is the thing, I tell you. It's much more than mangroves, it's the thing. lots of people are obsessed with grass. I find grass amazingly absurd and stupid, I have to say. It's sort of fragile like shit. You know, people that do this, you know, I mean, stinks like a very short period of time, decays like nothing. I mean, for an architect, grass is useless, I have to say. There's so many more interesting banyan trees and others that are worth looking at. I heard that you were sort of into green stuff, marijuana and things like that, but that's for probably when you have a drink. I mean, this is a project we were doing in Taiwan of a series of rather commercial towers, but the idea is to cross-bridge this sense of the park intertwining in its green with the surface of the building, and there are sort of in-between chambers which create a filter. They create not only the depth, but this environmental filter that is really important, and it goes from growing very tiny, small vegetation that is embedded in the skin to larger scale. And scale, I think, although people are talking about scale doesn't matter for architects, I think it matters hugely for biology. Because in fact, it's the control over the scale of small scale and the impact on the larger scale which does matter. And this was a project of Richard Beckett, who teaches with us, who was working for this facade on the idea that if you have a set of composites that respond to the climate, gradually the vegetation and the animals are sort of taking over, and what you create is a pattern that is completely unexpected. Actually, our predictive tools as an architect stopped working, actually. It's a complete useless. And I would say that anybody that is involved with real biological stuff needs to assume the third step, and this is this one here. You can't do without the third step, which is to say, look, this one is complete speculation. I haven't a clue, because this is when nature takes over its own rules, and it might go completely wrong, or not. I have no idea, because there's so many factors that you cannot predict. So our predictive tools clearly have a limitation there. There's something else. Steve Pike, who quite a long time ago now was using these sort of vessels, monitor vessels, and putting them in London and different places, he understood that the limitations of predictive tools were very clear. So by putting these biologically prepared vessels that were sere of vacuum formed and hermetically closed, and by placing them in different areas of town, were infected with the bacteria in the air. So that in itself was, I think, it's still actually really fascinating, because you know, the 20th century modernist understanding that air is pure and it sort of doesn't exist, and the sterility, you know, the sterile condition of architecture and the obsession with the white and, you know, whitewash and it's all complete rubbish, because in fact our presence and our programs in space fully qualify the air with bacteria. So if you have a surface that is responsive to that bacteria, it will grow the fungi that respond exactly to the bacteria that infected the surface. So on the left hand side you have the infection of the surface with bacteria from a bakery, which is all sort of I've forgotten now the name of the type of fungi which is really prevalent there, and you know, you get a whole set of other ones, the most dirty ones, the Bartlett carpets, the ones of the architecture students who sort of sleep on them, eat on them, do anything on them. So they are other, but they were not dangerous at least. But he was creating these big 1 to 2 vessels. And this brings me back a bit to the notions of making and the conversations about interdisciplinarity. I think one of the interesting things of large universities nowadays, and I think this is a challenge for your institution surely here, is that I think some of the most interesting stuff that's happening is existing in the crossing of disciplines. It's where your territory is stopping and somebody else's territory is starting. And that sort of cross path, some of the most innovative work is actually being developed. And you know, cross-disciplinarity, transdisciplinarity, interdisciplinarity, and there are sort of differences of nuance, but all this means that you can't work alone. You have to be networked with some other people who know other things. And Steve Pike really was one of those who was working with 10 different people at a time to create these monitor vessels. They weren't, impossible for an architecture student or an architect to do them alone. Just impossible. Even challenging the incubators in the microbiology department, because the incubators were far too small. As you can see there, this sort of tiny stuff. But from freezing cells that were or used to glass blowing at the Royal College of Art, to at the time, very primitive sort of CNC milling, to do rigorous pieces that were then vacuum formed, the use of vertical scanners, all that together with different techniques of handcrafted laser cutting. There was some tiny small milled components as well. All this sort of almost medical accuracy that you needed to create these monitor vessels was what allowed them to do them for the Holborn station at the time of the London terrorism, where one of the real big conversations was about terrorism in the London Tube. Anybody with a bit more expertise who would spread some really bad bacteria would kill or infect in the hundreds of thousands of people. So the obsession was really about creating biological monitors which could reflect very quickly, instantaneously, the type of air quality that is going through the London tubes. One of the reasons why this never happened, it was done for that, and there was a discussion with them. He, by the way, found out that there were genetically modified mosquitoes in Oxford Circus, which actually don't exist anywhere else in the world than in Oxford Circus, because it's sort of in the man-made condition of the tubes have mutated into this bizarre mosquito. So be aware, if you have them sort of biting you, that it's sort of one of those creatures. But the point is that the genetic modification of the stuff had to happen in order for it to regrow very quickly. I like this here. This is an artist in Holland who had just an idea of having a lamp which uses the most sort of trendy material that we have, which is algae. Just get into algae and it will be fancy and interesting, because you get into energy production, you get into biofuels, you get into food, lots of sort of issues. Then it's nice because it sort of looks interesting as well. It has a level of liquidity. And what he does and says, for those who don't know, is says, look, there's a lamp with some green algae in it, and algae needs carbon dioxide. So in order to put these guys on to start producing the energy level for the lamp to glow, they need carbon dioxide. So what you do is you come at home, you blow your carbon dioxide into your lamp, make a bit of sort of your air into it, and after a while they start glooming because they start producing photosynthesis, because they have the carbon dioxide to produce the energy. This is not fiction, this is a reality. And in fact, some people in Cambridge with some other scientists at UCL are working on really producing these rather ugly tables, but from an engineering point of view, interesting pieces, which is with very particular algae. There's a link that you can have to very tiny small wires that produce a tiny small bit of energy that could altogether create a lamp to glow. As I said, it's not at all a fiction, it's just in the happening. But the interdisciplinary teams that you need are obviously necessary. And this is Richard again, who designed this piece here with algae that is bioluminescent. And in a way, the thought that you have bioluminescent algae that glows at night so that you don't have any light on. It's only when darkness happens, these algae start producing their own sort of light. And the possibility that all these even office blocks and all this night light that is wasted can sort of switch off because you have bioluminescent and in part synthetically produced algae is I think pretty fascinating as well. I finish with going back to the algazebo, because the double curvature piece with all its sort of pattern was in fact a host for algae growth. That's what it was all about. It was not only a gazebo in the park where we thought to have it somewhere on a hill having beautiful views, and we were dreaming with this idea, you know, the old traditional chinoiserie or the gazebo that exists somewhere in a romantic, picturesque sort of environment. That was actually our imagery. I like the picturesque of the 19th century and the romanticism and the sort of level of kitsch, but I think it's quite interesting. Anyway, the gazebo was really something like that, but it had a piece of algae incorporated. And what frustrates me with a lot of algae work is that it's only surface-based, it's only sort of cladding, it's only just projected onto a building, and a lot of green walls are nothing more than, you know, a bit of cladding that could be a Richard Meier sort of white cladding, the same. And then, you know, there's a famous case of a school in London where they build a green wall, put the plants on. It lasts for half a year, then it was incredibly expensive, the plants started dying, they took it off, then they put panels on showing a green wall, so with illustrations of green walls, and then it became even more sad, they took it off, and now they just put some ivy growing into it, and it became a sort of English traditional building with some ivy growing into the green wall, because it's actually absurd, you know, with the English climate to do it. So the idea here was, hopefully, to do a study with particular algae that is embedded within very thick agar growth, which is potato starch, basically. And rather than having it flowing in a liquid, the nutrition for the algae is so fat that it doesn't allow the algae to flow. And so once you, with a syringe, pierce it into it, it actually remains within its own spot. The other thing is, as I told you, we were thinking about having these cylinders with different type of algae that respond and are infected by the environment to grow within these flutes of the algazebo. So the algazebo had, on the left-hand side, you can see on the upper part, a small seat for these views to be sort of contemplating the beauties of the park. And on the left-hand side, we had a bit of sort of biotech algae growth, which, as you can see here, was manufactured with the UCL algae team, and then carefully designed in such manner that it would fit into the pattern of openings. And here you can see it as it sort of was inserted. Also very interesting is, with all the computational conversation of people making things in different places, that you just hope when everything comes together that there is no expansion or dilatation of anything, and that things fit. And they did fit, because the steel work was all done without heat, and therefore no expansion of the material, and the accuracy is to the millimeter. So when the design piece from UCL was inserted with a crane exactly at the moment of the whole steel structure, the core 10, it was absolutely fine. And here you can see sort of how you could look through the sides of these different algae pieces. There's another one here, and at the end the thought was that sort of you could also have some light. Sorry, actually on the previous image, on this right-hand side, another interesting thought was to play with some 3D printed models that mimicked an algae sort of geometry. Then these 3D printed models were impregnated with carbon, and that meant that the algae was actually growing not only within the medium that was very stiff, but also it was attracted by the carbon, which was the feeder of this 3D print. So the notion that you design something impregnated with carbon, the algae grows around the carbon and has stayed within a thick medium for quite a long time, because we had to grow this for 2 months without being completely spoiled, with some bioluminescence, is what then sort of at the end ended up being this. Like everything that architects do, in particular in academic environments, there's a lot of wishful thinking. So bioluminescence happened in 2 or 3 of the vessels for around 3 days, and after that we needed some electric lights that were in fact coming from a bit of solar panels to gloom, because the bioluminescent algae have the problem they come from the sea. they don't grow in fresh water, they grow in seawater. So the need for having seawater within these vessels was completely impossible. We kept them there for a few days, and then off they went. And we had some artificial lighting giving them the glow in the space. I finish here, but I wanted to show you, before I finish, this small sort of video. Is there some sound? This is stuff that inspires me. I just want to share it with you, because the other day I was looking for another talk about sort of a small film of what really turns me on right now, what inspires me. And you know, you see so much stuff, but this one, I think also with the voice of Atelier, this is stuff that I like most. Some of you might have seen it.
Some corals are male and release clouds of sperm.
Oops.
A female will be releasing eggs. Other species of coral are both male and female. These release packages of eggs already pre-wrapped in sperm. Of eggs and sperm float to the surface to mix with others from further along the reef. Each kind of coral times its release to a certain hour on a certain night. That maximizes the chances of cross-fertilization. The fertilized eggs drift away from the reef.
Marco, wouldn't it be amazing if we could do this? That's what makes me dream. Thank you. I don't know how late it is, but I didn't talk for too long, so it's okay. No, we need more light. Yeah.
Hello. Impressive lecture. Very interesting. I'm a little bit curious because you show us a lot of materials and inspiration from the nature and processes of fabrication, and on the slide you show us a lot of shape, sculpture or baroque form, and I was wondering what's your position or your point of view about letting the material express and being the generator of the shape. I don't know if it's clear.
Are you asking what generates the shape?
No. What do you think about letting the material express himself? Because you speak about like your experience in the Le Corbusier chapelle. You were saying that you liked the idea of seeing the craftsman work and seeing this effect. And on all the project you've shown us from Bartlett, we have a lot of incredible shape and incredible visions, but there seems to be really from the computer without really taking into account the fabrication process. That is not a problem, but I was thinking, do you imagine to shift to something that will let like all this biomaterial that you show us, they have a kind of texture as well and something to say about? How do you think it would be possible to mix these things?
Do you see, I was saying that we shifted the pedagogy in our studio by starting with materials. And it's exactly because of that, because there was so much of a one-way thread whereby people were creating all these computational models and then fabricating something at the end. But clearly by starting with the materials is in order to get a level of sensibility and expression that turns the process much more difficult, I have to say. But it's, I think, much more fascinating. It's much more sort of real. Now, when you say let the materials speak, I'm not nostalgic for wood to speak on its own. I don't care about wood speaking on its own. I like somebody who crafts the wood in such manner that the wood becomes really something special. And where the wood, as I mentioned with the Bernini case, where wood could speak like any other material, I think that's a sort of an achievement that is beyond wood. Yes, it's nice to have some vernacular piece of wood or steel or foam or whatever, and obviously if you get into composites and new synthetically produced materials, they have their own rules. And do you know where I really learned, I think, to at least understand a bit better what materiality meant was when we did a workshop in Copenhagen. And I think the Scandinavians have a sense of materiality that the other Europeans usually don't have. The other Europeans are far more formal, and the Southern Europeans even more. They really think about form in the first place. The Scandinavians are obsessed with something that with a certain level of performative materiality. And I remember we started talking about some materials, even some basic flexi-ply, really basic. And there were immediately some students taking these, making experiments and trying to see how much could they bend the material. That was their achievement, sort of saying, if I can bend it really a lot, what can I do with that? And in fact, at the end, they produced some rather sculptural, but stuff which was incredible, because what they did was they spent time first understanding the capability and performativity of the material, and then started becoming computational by drawing and three-dimensionalizing some of the stuff they had already worked with. So they knew the radius, for instance, of how much they could actually bend. And then that one led into sort of looking at how certain components could be sort of standardized and then intersected and so on. So that made me think that the order in which we were used to do it was a sort of, I wouldn't say a wrong order, it was just simply an order that didn't interest me at the time anymore. I'm more interested now in coming from the angle of, let's do a few material studies, let's understand them, let's also give different people different material affinities. It's almost like an empathy you create with materials. I think there's something about that, you and your material, or the set of materials, it doesn't have to be one. And once you gain that level of empathy, you're probably starting to have a dialogue, which then with the tools that you might use, can create something extraordinary. And all this becomes incredibly complicated if you get into biomaterials. Haha. With biomaterials, bloody hell, Bernini and biomaterials, you can imagine what sort of what brain fuck that is, because it's sort of the thing is growing on its own. It's what I was saying with biobricks, the thing doesn't stop. You can make it stop if the coral is sort of dead, yes, but the possibility that the thing is still having its own life cycle and has its own capability of emergence and development, I think is really intriguing. And perhaps for those who are going down this route, our role of predictive thinkers and controlling people of the mechanisms to put something in place will have to consciously stop as what I call the second step, because the third step is something else. It's out of your hands. I like the architects who are not dictator architects. I like them more than the dictator architects. I find the sort of the obsessive people who don't allow anybody to do anything to your building, your own building. I find them really sort of rather sick. But I like the fact that a building could turn into some other function, for instance, or that there was some level of change in a piece of architecture. I don't mind. Even in our pieces, when we design them, we are obsessed with them. But if something goes wrong and somebody else has an idea, I rather enjoy that actually. I don't mind. But with biomaterials, there will be a different cycle of thought that probably will come much more from the expertise of those who are you working with. You know, being them biologists or biotechnologists or ecologists or, you know, whoever, engineers. So sure, I'm with you on that one, with the materials having a bit the lead. I think we are in that time. I'm not the only one talking about it, to be honest. I think there's a whole range of people talking about materiality. Marjan told me that he calls it materialism, and I said, materialism? That's a sort of funny one. He said, oh, it's very trendy now to talk about materialism. I said, I'm not sure about materialistic thought. I think it has a political connotation, which is odd. I call it paramateriality, which is, you know, when you have Paralympics, you have the Olympics for the other thing. It's sort of the ones that can't run and need something, need the artificial leg. I think with materials a bit like that. You need a tool to create something because on its own it can't do it because it's completely artificially produced. I think it's a paramateriality thinking that we have in place. It has to do with how we manipulate our tools and the materials themselves that we are using in creating. The reason why I mentioned the biomaterials and this whole range of materials, I think new materials is something that for us architecture schools we should really embrace. Because if you think, the history of architecture has been hugely influenced by the use of materials. Once certain materials kick in, you have whole styles that are based on certain materials. There's no, you know, it's an intricate relationship. And I think our world of materiality is not yet there. And if you think how many architects and schools of architecture are really embracing material sciences? Very few, extremely few. It's a given that you use the materials that are around. So I think we are the first reason of this limitation, which is that if we would have a whole tradition of constantly messing around with stuff that is sort of on a limit, we probably would know by now what it could give us, much better. And I think there's another level, which is if the material has an environmental / structural capability, and these are two grand roots. The ductile stuff, for instance, mix ductile with bioconcrete. Might be quite fascinating, because bioconcrete has a capability of restoring cracks and age. Ductile has the capability of being hyperdense, create enormous spans, be incredibly thin, introduce lightness. So I think if there's a structural capability, then that might be a breakthrough. Whether they are biobricks, I don't know. One of these things somewhere, at some point, and I know that Ginger Dozier, I was at the University of Sharjah the other day there, she was not there, she's in America trying to get it done as a commercial product. So I wouldn't be surprised that in a few months there you have sort of catalog and you buy the biobricks, and she's becoming a sort of millionaire because she got the patent for it. So I think that is one issue. Do you know the other one that I'm thinking about? Something's very noisy right now, but is the issue of the user. I think we are not at all prepared. Do you know, I think we are still looking at the green wall and this bio stuff as if we are normal users. In fact, and to a large extent, we find it a bother. We like looking at it. We as architects love the idea of designing with it. But in terms of the user, nothing changed. And I think one of the great changes that probably is going to happen, or has to happen, is that users are going to look at the architecture and treat it much more as gardens. Because if you think, you get to a country like the UK and people are obsessed with gardens. They spend hours in gardens. You go into their house and often the house is a shambles, it's terrible, but the garden is immaculate. I mean, they spend fortunes in their gardens. And every cycle they buy new plants, they are the gardeners. And I think back when I was in school, in high school, you know, I was a big lover of Hermann Hesse's literature, you know, and Hermann Hesse has a sort of beautiful story where he says we are all gardeners of our own self. We treat ourselves as gardeners, which means that we have funny plants, roots, seeds, and some people like French gardens. They like sort of to prop it all off and do grand geometries and have it all planned. Others like English gardens. Others like forests and wild stuff. It depends who you are. But the idea that you extrapolate the psychological behavior and manner to how the architecture needs to be taken care of means that there's a level of maintenance, a routine, which is not a bother, it's actually part of the pleasure. And that's why you get to the English Chelsea Garden Show and you have people spending in the thousands of pounds in gardening stuff and buying the most exquisite plants. Why? Because they love this relationship with something that is growing. And I think if there's a shift in our society where this becomes a more integrated condition, where we have it closer to the architecture, then taking care of what we are building with might not be an odd thing, might be just a shift of mentality, of attitude. Because somebody the other day asked me, so what's the functional usefulness of having biological stuff on your wall? I said, actually there's no functional usefulness at all. A bit of environmental thing, yes, okay. You know, on the streets, if you have more trees, it's greener, it's better. But it's not the functionality that does it. And the grand steps in architecture have never been done through functionality. It's not the need that makes it. It's much more to do with this combination of a new material, new ways of doing, but also how the society starts shifting its position towards what they are doing. And I think there is something around there that we probably are facing that, you know, I see Marco and Claudia sort of doing all these installations. It's a lot to do with behavior. It's a lot to do with interaction, of people interact, is teaching them to interact, actually. Isn't it? It's a lot about that. Because it's not so much about the technology itself. It's about you behaving differently because you know that what is around you is a different context. So I think that's another grand limitation. And then maybe, just the last one, is to do with our tools. It's still all incredibly complicated, and for instance, algae. Why are algae not being used in mass-produced fields? Because biofuel from algae is incredibly inefficient. Every single scientist in the laboratories tells you that they are spending millions of dollars and pounds in investigating something that so far they know is completely inefficient. That's why you don't have them on a large scale. So there's a level of inefficiency of the matter itself that we haven't cracked somehow. Therefore, I find conversations with scientists really interesting because we're just waiting for something like that happening and then importing it. Where the interdisciplinarity comes in. Of course, of course. Of course, of course. About safety. look, I'm not a scared person, so I give it to an engineer. He will sort it out. I don't have a problem with safety at all. The only thing I would say is that there is indeed a danger with certain species being released. That is a danger. And all those who go into microbiology departments are not allowed to work with certain species because they're simply dangerous. If you take certain algae and release them into the environment, you get new parasites and threatening species, which could completely and utterly change the sort of balance that exists in the environment. So if you know, it's the what are they called? Not the chicken pox, the other pox. It's that sort of phenomenon. Okay, so if you release that, you can create chaos. But that's not what one is talking about. You know, does it everything needs to be genetically modified? I'm not sure. I find quite of the bio artists quite interesting, the ones that don't need to genetically modify, the ones that actually work with much more primitive tools of cellular intervention. So, you know, what happens with the guy that was doing all these manuta vessels and putting them around London? None of them is harmful. Looks sort of threatening, none of it is harmful. You are surrounded with bacteria and stuff that is much worse around you. You go into you sleep probably in a room where you have humidity levels that you are not aware of, which are really, really harmful. But you know, you live with it. This stuff doesn't have that. So I would worry a minute. You know, I think there is, if you start like that, you never develop, you never move on, basically.
You mentioned biopolitics. You mentioned biopolitics, and your research is obviously influenced by the less studies on Baroque and the Fold. That at least I understood that. And now there's something inherently violent about this show, the work.
Inherently
violent. There's a violence in the work you showed us, I think, and that comes from the association with the human flesh, with the flesh. And I wanted to ask whether you consider the human body as a potential material for the architect, and whether you consider the political implications in such a thing.
Interesting. I have to say, I've never thought about the work being violent, but maybe there's a, you know, my working and teaching partner, Marjan Colletti, calls it cute. So you can imagine how far from violent it is. But sure. I do find that we're living from a philosophical point of view, we're living in a weak period. Okay, this is what quite a few philosophers have sort of written about. We don't live in a strong period of philosophy. It means that if some people claim that we're living in a modernist period, we are not in modernism. I'm a deep believer that we are completely embedded in postmodernism. Or in our Bartlett catalog, I just wrote down on Frederick Migru that we are living in a transmodernist probably period, means something that has trespassed the modernist attitude of positivism. So to some extent there's an indulgence with the negative, with the fragile, with the vulnerable, which can in times be probably violent. And I haven't shown you any body images because I have a quite good sort of repertoire of spooky stuff at home. You know, I'm not the only one. A lot of fine artists, in fact, portrayed the body, the contemporary body, the cyborgian body, as a very, very grotesque, fragmented, monstrous figure. And I think there's a truth about that somehow that makes us realize that this sort of positivist compositional balanced body doesn't exist. It's not the body of our time. Leads me to a completely different story, which is the whole relationship between our body understanding and architecture, which is seriously fascinating. In fact, I think we are in a crisis of the body because architects have no clue about the body, actually. You get hardly anybody drawing a body because they're completely paranoid. I feel paranoid to draw a body in another sketch. I draw it and I'm not sure whether it's the right sketch of the body. Because you collage a body into a drawing, you think, let's make it dark and black to sort of do as if it's not there. There's an American journalist which called it the scalies, which is the phenomenon, I don't know if you have heard of it, the phenomenon of architects who are in complete crisis with the body. They only put collages of top models with doggies and skateboarders in, which he calls the scalies, in order to give scale, but they haven't a clue how to draw it. So the idea of Erich Mendelsohn drawing the buildings as he was drawing the dresses of the women and the bodies, that relationship doesn't exist. And I think it has to do with the fact that we haven't questioned who we are, really. There are very few people really talking about that violence, that inherent sort of political state we are in, where our body is not the correct body. It's a body in transformation. It's in fight with technology to some extent as well. And the idea that our skin is obsolete, and in a way the thing doesn't finish where our flesh is. There's another level of flesh that goes beyond our flesh, which is this extension of our haptic understanding. You know, Stellark sees it as the obsolete body as an opportunity, but you have quite a lot of artists seeing it as a really negative, dangerous move. I don't know. You know, your comment in hindsight makes me think that the implicit violence of some of the work is probably the result of these conversations with the students, who are aware that their references are about a whole set of imagery of artists' work, where the notion of fight against the establishment, where the expression of the body as an entity who inhabits these buildings, have a reflection in what we call the figural. And I didn't delve into that before. The figural, I think, is a very contemporary condition. The figural is neither figurative nor abstract. It's something of another condition. It's a Deleuzian thing, but it's also a postmodern story of Lyotard, who talks about the figural. The figural is potentially grotesque, is potentially expressive in a manner that we find rather scary. It's not pleasant stuff. I don't know. I mean, we need a few drinks to talk about it, basically, and maybe something else. But there seems to be some last person. Bio-ornaments. You know, I don't know exactly what you're referring to when you say bio-ornaments, but I tell you what my interpretation is, and that is that ornament, as opposed to decor, for me is something that is culturally and structurally ingrained, has a tectonic dimension. That's why I like ornaments. I think we are returning to this figural condition of the ornament, but I'm not a great fan of decor necessarily. Now, this culturally, tectonic, structurally ingrained condition of something that is an expression of culture, that is the ornament. And look, we are living in a city which the best architects did use ornaments, the crap architects use decor. And you can see it on a simple fact. Sorry, I'm digressing for a minute, but just about because we are in Barcelona. I remember when I was a student here, I was walking down the streets thinking, why are people like Puig Cadafalch or Domenici Muntaner, why Jujol, obviously Gaudi, why are they more interesting than the other guys? Although some of the other facades are amazing as well. Why are they better? And you realize that the other architects, which fill 95% of the ensanche here, have pretty straightforward typologies, the most basic orthogonal facades, and in fact they're straightforward buildings, beautiful pavements, but just very, very straightforward buildings with very good craftsmen who did all the decoration of, you know, the decor of the buildings with beautiful doors, amazing lifts, you know, all the exuberance of Barcelona buildings and flats. But these other guys didn't stay there. When you look at the substance of the architecture, there are structural challenges and tectonic challenges which are amazing. They're usually typological twists. Gaudi was a master of typological twists of how buildings with one courtyard turned into 3 courtyards, with staircases in behind somewhere that linked room number 3 on the 3rd floor with room number 1 on the 1st floor. And the sort of bizarre stuff that you thought, did really the family Grail need that? No, probably not. But actually it was a sort of interpretation of the program. Now, I'm saying all this just to differentiate decor from ornament. So if you go into biology, I have a bookatome which is on seeds and some photographs. It's from the Kew Gardens Millennium Archive. I don't know, have you seen it? It's amazing. It has the most sort of dreamlike photography of seeds on a macroscopic scale. They are to die for. I mean, anything that we do here is crap when compared in terms of its sheer exuberance, of its sheer level of perfection, but also imperfection, which is again this funny thing. It's completely imperfect. Nothing that repeats is the same as really perfect. It has this notion that Marjan was talking about, forgot the name that you used, the exfoliating. Okay, this notion of the exfoliation of the skin happens in all of them. So I would say that the bio-ornament that interests me, and I find surely interesting to look at, are those cellular structures where there's an implicit, also structural capability that allows these very tiny small elements to be plankton in the sea, floating around, but to be incredibly resistant to its environment. But with a complexity of its own structure that is fascinating. And the cultural side is that we like that side of scale. That's what influences us and what is challenging for us. It's that particular scale that we're looking at. So I think nature has a lot of that we sort of we just, you know, we have saliva running down our tongue when we look at some of these images and think, gosh, the next pavilion should be something like that. But hopefully not only like a skin, you see? That's where the flatness of the thing becomes sort of odd, which these cells don't have. They have this ingrained depth, which is more interesting, and then the Velasquez conversation comes in and blah, 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 blah. So I don't know. Nature has so many layers, but then I wouldn't replace nature by what we do. I'm much more fascinated with the notion of the bioextension or the bionic, which is the idea that biological stuff can be also extended by our intervention, than being a sort of freak that believes that only nature has to be kept as nature, because there is no hardly natural nature anymore. It's so subverted everywhere. So I think there is a level of complexity that is multi-layered that we need to look behind the scenes. So don't take, basically what I'm saying is, don't take a pattern of a cellular scale and turn that into a large scale. It just doesn't make sense. But if it has more layers, if you start talking about more things, somebody the other day did a project on, I'm getting so tired that I'm forgetting the words, on lichen. Lichen? Lichen is amazing. Lichen is an algae and a fungi at the same time. You do a section through the lichen, it's extraordinary. And it's amazingly intelligent as well. The fact that one needs the shadow of the other, needs to feed from the other, and you get into sort of symbiosis. It's fabulous. You get the most incredible projects if you do a sort of a lichen project. So yes, I think there is, if you extrapolate on that level. Anyway, cheers.